So yes, we are going to talk about the dissemination of contextualized statistical information, and in particular the interoperability between CDI, DDI, CDI, and NGSILD. So I will try to explain this rather arcane title. Next slide, please. So what's the Interstat project? So this whole work takes place within the Interstat project. So Interstat project, the overall objective of the project is, let's say, twofold. First, to develop a framework to allow interoperability between National Statistical Portal and the European Data Portal. So most of you probably know the European Data Portal. If not, just go to data.europa.eu and you'll find it. And so one objective is to develop the interoperability between this portal and the national statistical portals through the development of technical assets, of models, ontologies, etc., etc. The other objective, or the other side of the main objective, is to deploy cross-border services that reuse statistical open data from these portals, so the national ones and the European ones. This project is actually funded by the Connecting Europe facility, as you can see in the upper right side of the slide here, which is a big program for improving interoperability within Europe. And the project consortium, so INSEE is there with the fellow institute ISTAT from Italy as data provider mainly. And we have two big technical partners. One is engineering, which is a big IT company from Italy. And the other one is the Fireware Foundation, which is a foundation based in Germany with big tech members like Atos, Telefonica. That's rather big tech. Next slide, please, Arfan. So the more precise objective of the Interstat project, well, I have listed them here, but I'm not going to go through each of them, but rather to focus on the one which is highlighted here, which reads, the objective is to provide uniform technical interface for a standard and simple reuse of statistical information through the adoption of a building block which is called the context broker, actually, which has been standardized by this Connecting Europe facility, and through the implementation of the NGSILD API specification. So we'll see what all this is in the following slides. Bear with us for now. Next slide, please. So in order to do that, so of course there are different activities within the Interstat project. We develop technical platforms, we develop models and ontology and these kind of things. But we also work and actually we drive our work in the project by cross-border pilot services. So we have defined 3 pilot services that will help us to define what is necessary in terms of ontology, in terms of technical developments, etc., of platforms. The one that we are most advanced on, and the one which is driving the current work on interoperability, is the last one, the support for environment policies. And this use case actually has the objective to support local policymakers who have to take decisions about environmental policies. So, for example, a mayor which has to take a decision about where to locate some pollutant device or something like that. And for that, we will use in combination 2 sources of data. One is sensor data regarding the air pollution, which gives a concentration of pollutants in diverse localizations. And the other one is the one we are producing with Distat, which is the statistical data regarding the demographic characterization of the city or of the area. And this is actually based on the census data. Next slide, please, Arfan. So as I said, the objective, which was highlighted 2 slides ago, was to use the context broker, the Connecting Europe Facility context broker, in order to disseminate statistical data together with other kinds of data, for example, pollution data. So what is this context broker thing? Well, basically, it's a data broker, of course, but it's data which is contextualized. And what is contextualized data? Actually, it's data which is aware of the context of the consumer of the data. And in particular, its context in terms of space, in terms of times, etc., etc. So we can broadcast data which is more relevant to the space and time where the data consumer is. For example, it will broadcast data which will be relevant to the localization of the user. That's all there is to context data. That's what we call context data. And this context broker is the kind of a generic building block which is specialized in disseminating this kind of contextualized. Next slide, please, Alfred. So how does it work? It's basically a pub-sub model for those who know this model. So the context broker itself, it allows data producers to publish data to the context broker through a REST API. So they can update a channel or a topic that they publish through. And on the other side, you have the context data consumers who can query the context broker on specific topics, on specific subjects, or who will be notified by the context broker if they have subscribed to different topics. So the context broker receives the data from the producers, disseminates the data to the context consumers, and manages the subscriptions of the data consumers. In order to do that, the context broker, at the heart of the context broker, there is an information model, of course, which covers, first of all, the API. We saw that there was a REST API behind the broker, but also an information model. So all the information within the context broker will be conformant to an information model. And this information model is the information model defined in this NGSILD information model. So here we go with NGSILD. Don't ask me what NGSILD means. LD means link data because it's on RDF. And NG is probably new generation, and I would say something information. Anyway, that's the standard. It's been standardized by ETSI. And it's the de facto standard for context information. So think Internet of Things, smart city, smart cars, smart whatever. That's the de facto standard for the dissemination of such kind of information. The model itself is layered in 3 kind of onion rings. At the core, you have a very simple meta model, which is called the core meta model, which for those who know this kind of models is what we used to call in the ancient past property graph models. It's a bit more expressive than RTF. It's easy to translate it in RDF. Then around that, you have what is called the cross-domain ontology. This is a thin layer of just a handful of properties, which are, or classes of properties, which are defined above the core meta model. So obviously things about time and space, because we are disseminating complex information. And then on top of that, you have the domain-specific models, which are called the smart models. So next slide, please. We have the example of Arfan. After the next slide. Yeah, thanks. So to define this data model, so these domain-specific models, there is actually a very nice ecosystem, a community, which is functioning on mainly on GitHub and with principles like openness, like reuse of standards, etc., etc., and which allows actually communities to build their own model, which is relevant to their domain. For example, data, smart data, smart cars, smart weather, smart whatever. They have specific. And if we go to the next slide, it's a bit late. we have the kind of overview of how these data models are organized. So, as we said, we have smart models which are relevant to different sectors, so smart water, smart city, aeronautics, energy, etc., etc. And these models can share different classes and properties which are relevant to one given subject. For example, if you have the subject of weather, it will be reused probably between smart environment, smart cities, smart energy, probably smart analytics also. But the idea is to have this kind of two-level organization. You have the smart models, and then you have the subjects where you can share the different constraints within the smart model. And with that, I think I give up to you, Arafan.
Thank you, Frank. I should mention, and this becomes relevant when you start looking at the technical aspects of this, that the smart models are maintained. It's a very interactive process with the community of users. And I think that's a kind of unique feature of the way that they're created and maintained. It's a coordinated set of domain models, but they get updated a lot according to the people who are using them. And that's, I think, a significant aspect to them. But it does mean that they can change potentially quite often. The key problem here that we're looking at in the prototype is really how do we interoperate between the models that we have the data in, like the SDMX model for statistical agencies, VTL in some cases, which is a validation and transformation language that Eurostat uses a lot, and things like DDI, CDI, and other kinds of models that will be the way in which the producers hold this data and describe this data today and distribute it. Because you can understand that there are a lot of different inputs when you think about not just the pilots that we're looking at, but more broadly all of the sources of government data at the national and European level. So the point of this pilot is to look at this problem and to try to figure out how we map the data formats into these NGSILD smart models fundamentally, and into the reusable subject blocks. And so although we're starting with the two pilots on environment and the facilities, we have to be prepared for this to become a much broader thing. And if you take some time and look at the NGSILD domains and the smart models, you'll see that it's a really broad base of coverage. So they anticipate a lot of people using a lot of different data here. So we've started working on this, and the modeling we've done is primarily in as Frank said, the SEP pilot. And what we have there is data coming from the European Environment Agency. And then they have a data dictionary that they use. They are very sophisticated in terms of deploying RDF on a technical level. And they are quite a forward-looking agency in terms of the data they have. A lot of the data itself that they collect is sensor data. Most of what they distribute, my sense is mostly aggregate data, but they supplement that also with kinds of aggregates that you don't see in statistical agencies very much, because they're very focused on the sensor readings and their sources of data. And that's true at least of their air quality data. They have a lot of other data there as well. The other data we're looking at is the demographic data, the census data, and that has been done in Europe. That was really the model case that Eurostat used to drive the adoption of SDMX in the statistical agencies at the national level in Europe. And alongside SDMX, you have the W3C data cube vocabulary, which is based on the same information model for describing data and data structures. That's important because this is a very deeply RDF initiative. And you might have seen that in the earlier slide that Frank showed when they were looking at the mission, although he didn't talk about that. This is not an XML implementation. This is very much an RDF implementation at a technical level. So we've taken a look. Go ahead, Frank.
You've got 5 minutes, Arafan. Is that okay?
Okay, very good.
Yeah.
When you take a look at the modeling for the pilots, you have so these data and metadata models that are based on SOSA SSN, and we've been applying DDI CDI to those. Part of the problem is that we're looking at multidimensional data, at aggregate data cubes, but also looking at things like wide tables. And I'll show you an example of that in a second. turns out that there's an awful lot of different data that has to go into the context broker and to be mapped against these models. And maybe the best way to understand this is to look at a workflow of the example that we worked at the recent workshop at Dagstuhl in this past September. You have a lot of different source data. It might be SDMXML. A lot of the data itself is going to be coming in CSV files. You might have DataCube. The facilities data that we were looking at for that project was very much wide tables. It's a register of things like schools and cinemas and playgrounds, geolocated in France with some descriptive variables, but it's very much a rectangular data set. And you can imagine that there's a lot of other different forms of data that will be available. You also have what are termed quality reports or reference metadata in SDMX terms. And at INSEE, they've done an RDF vocabulary for describing that based, again, on the SDMX model, not for data structures, but for metadata and descriptive metadata. All of that stuff gets bundled into an RDF binding of DDI-CDI, into a DCAT envelope, if you will, which is a little bit of a profile we use to combine the pieces, and then this descriptive metadata. And the idea here is that you would have a single intake format in order to feed the NGS-ILD smart models. Now, whether that's one transformation or a handful of them, the point is it's not many to many, and the prototype is exploring how to best sort of achieve that balance. But it's quite a bit of an exploration in terms of mapping these models. I'm not going to go into the turtle. It's too early in the morning here in the US, but you can see that we actually have a GitHub repository. You can see the work as it's ongoing. I don't think you put the link in, Frank, but so in this case, you have DataCube stuff being mapped against that sort of into the format that we would want to see it. But we're working already on doing examples of all these things and what those transformations would need to look like. In terms of future work, a part of this is going to be to automate the transformations we've been looking at into NGS-ILD, which means looking more at those models and seeing if the domain models themselves, the target models, have what we need. And we think that they're not 100%. There's a lot of common things like DCAT and SCOS that we use, but then there are things that are very much specific to the data, like the DDI-CDI structural descriptions, like the way we describe things based on SDMX. And so we expect that the NGS-ILD people will have to update some of their smart models to accommodate specifically the statistical data that's coming in. But that's basically what the future work holds. I don't know if there's anything you'd want to add to that, Frank, because I think that is the last slide. Yeah.
No, I don't think I would like to add something. Well, just maybe, yes, you just, if you can go to the previous slides, yeah, we can maybe stress the case of the SDMX metadata model, because you mentioned it, but that's the model which is used in, well, at least in Europe, in order to produce what we call quality reporting. Actually, it's a bit more than quality reporting. But for example, when we transmit data sets to Eurostat, usually we accompany the data with a quality report, which is conformant to a model, which is actually a SDMX metadata structure. And so the fact that we can map the SDMX metadata model to NGS-ILD means that we will also be able to produce descriptive metadata, and in particular quality metadata along with the data through the context broker.
It's probably worth pointing out, Frank, that when Eurostat says quality metadata, they're talking about things like embargoes, like methodological information. A lot of what you would describe in a DDI instance in that world is seen as quality or reference metadata. It's information about the data set, but it can be tagged against at any level of the data structure, in fact. They have a way of attaching
you're right.
to very specific things, which is quite nice.
I put some quotes around the quality metadata thing.
Yes, exactly, Frank. So it's pretty wide ranging.